Hello everyone. Today we are excited to present our selected conference paper. This is Smart Baby Incubator, a modern approach to infant monitoring and control. We are group 26 and our group members are Leilala, Madhushani, Shamali and Yaparatnan. Next we will move to the introduction and background of this work. The paper we are presenting was written by Faique Ahmed and co-authors from Islamia University of Bahawalpur in Pakistan. It was published at the ICE Cube 2021 conference held on October 26th and 27th. Since then, it has been cited around 12 times. The core focus of the paper is to design a smart incubator system that not only controls the incubator environment but also continuously monitors the health of the infant using modern technologies. So we will move to next slide. Now let's consider why this topic matters. Premature infants are highly vulnerable right after birth. Their organs are underdeveloped and they need continuous monitoring in a protected environment. In traditional incubators, nurses and doctors need to constantly check on the baby and manually adjust the settings like temperature or oxygen level. This can lead to delays or human error. During the COVID-19 pandemic, the problem became even more serious. Access to neonatal intensive care unit was limited to reduce infection risk. This situation highlighted the urgent need for remote care solutions. That's the motivation behind this research. So we will move to next slide. The paper shows the three key goals. First one is automate the control of the incubator's environment like temperature, humidity, and oxygen levels should be regulated automatically. Second one, monitors the baby's vital signs, including heart rate, body temperature, and oxygen saturation, as well as detect infant crying. Third one, enable remote monitoring using IoT connectivity. So nurses and medical professionals can access real-time data from any location. Together, these objectives aim to make neonatal care smarter, safer, and more efficient. So we will move to next slide. So, what makes this incubator different from other solutions? Firstly, it doesn't just monitor the incubator environment, it combines that with real-time monitoring of the baby. Secondly, it includes an intelligent cry detection feature using a microphone and sound analysis. This means if the baby cries, even when no nurses is around, the system can detect it and trigger an alert. And third, the entire system is connected to an app or cloud platform which sends real-time alerts to medical staff or parents. This combination of features, especially remote alerts, cry detection, and dual monitoring of both the baby and environment. I'll now hand over to Sahan. He will explain the system design and methodology behind this solution. Thank you.
Okay, thanks, Dimansa. Now, let me explain the overall system architecture for the system Smart Babies Incubator according to the conference paper. At the core of the system, as you can see, we have the sensors, the control unit, and the actuators, and also the incubator continuously monitor essential parameters from it sensor like heart rate, temperature, and humidity. And then it uses this information to automatically control the environment inside the incubator and the camera for visual monitoring and an LCD display to present real-time data. Let's move on. Here, as you can see, the details we were the system components. Let's dive into deeper in the system. So first of all, let's discuss key components. In here, the brain of the system is an Arduino Uno microcontroller. Uh, connected to this microcontroller, we have various sensors like the DST11 for temperature and humidity monitoring, and then the max tier 30, 100 for measuring heart rate and blood oxygen levels. And then a skin temperature probe is there, and then a microphone for detecting cries. Next, for the actuators, including a heater and a humidifier and a fan, and also uh, all connected based on the sensing inputs. And then for the communication part, here we got an ESP8266 Wi-Fi module. So then it sends data wirelessly to an app cloud services. Let's move on. So let's quickly review the main sensors used for the monitoring. So the DHD11 sensor checks air temperature and humidity continuously, and then for the vital signs, the max 3000 sensor measures the baby's heart rate and saturation critical indicators of the infant well-being. And then the microphone detects crying sounds, signaling distress or discomfort. And additionally, there was a camera integrated, so it allowing caregivers to visually monitor the baby from anywhere. Uh, so let's move on to the next slide. So now we have to discuss the control logic of the incubator. Um, mm, so let's think how does the incubator manages these input. Actually, the system uses straightforward but effective control logic based on predefined threshold. Uh, so if temperature or humidity drops below safe levels, the Arduino automatically activate the heater or humidifier to restore optimal conditions. And so that the key here is real-time regulation. The incubator continuously adjusts to maintain a stable environment. So this will ensure consistent comfort for the infant without needing consult manual intervention. So let's move on. Another innovative aspect of this system is the system's cry detection capability. In here, just in the microphone, the incubator can detect cries from the baby, which typically indicate distress or urgent needs. So that when crying is detected, the system immediately triggers alerts and interactive to caregivers to a smartphone app. While the current implementation is relatively simple, they mention future developments may incorporate quick machine learning algorithms such as Gaussian mixed models or convolutional neural network CNNs to classify different type of cries for a precise care response. Let's move on. So finally, as you can see, let's talk about the remote monitoring and IoT connectivity. The ESP32 module transmit real-time data to a server or cloud, and then it will making all monitoring information accessible through a dedicated mobile app. And also, caregivers can remotely view environmental conditions and the baby's vital signs at any moment from anywhere. So, if the system detects an abnormal conditions, the app will immediately sends a notification and then allowing swift action, so that this integration significantly improves monitoring efficiently and response time, so that this will ensure better care and safety for newborns. So now let's move to our next presenter who will cover the results and key finding of the system. Thank you. Prasad, over to you.
Thank you, Sahan. Now I'll present the key results from the Smart Baby Incubator project. So let's go to the next slide for comprehensive monitoring. This system achieved simultaneous environmental and infant health monitoring with remarkable success. The automatic temperature and humidity control showed successful stabilization within the optimal range. So for environmental monitoring, they track temperature, humidity, oxygen level continuously. On the infant monitoring side, the system successfully measured heart rate, SpO2, body temperature, detected crying patterns, and provided visual monitoring through integrated cameras. So let's go to the next slide for cry detection results. The cry detection system showed impressive results during the testing. So they successfully identified infant crying during audio playback test using a threshold-based detection method. So that effectively distinguished actual cries from background noise. The smart alert logic was particularly effective. The system intelligently ignores short whimpers to prevent false alarms, but triggers alerts after a predetermined duration. So let's go to the next slide for real-time IoT monitoring and immediate alerts. So the IoT integration transformed traditional monitoring capabilities. Unlike traditional systems where bedside alarms only work when nurses are physically in the room, their smart system ensures alerts follow caregivers wherever they are. So alerts appear on the mobile app within seconds, covering temperature, humidity, vital signs, and crying, all monitored simultaneously. They successfully tested alerts received from different floors via hospital Wi-Fi and even demonstrated successful remote monitoring from off-site locations. So in the next slide, we go into stability results and safety features. So the stability testing revealed excellent system reliability. The heater and humidifier operated smoothly without any erratic behavior or rapid on-off cycling throughout the extended testing periods. So critical safety and fail-safe features ensures continuous operations in case of network failure, and local control remains active and data is queued until Wi-Fi is restored. The keypad interface enables manual override by nurses, ensuring baby safety is maintained even without internet connectivity. So in terms of improvements in the system, in the existing systems, this solution monitors more health parameters than previous ones and provides instant alerts instead of delayed manual detection. So that's about the results and key findings. It's over to you, Sriji.
Thank you, Prasadi. To conclude our presentation, let's reflect on main outcome of the conference paper we review. The authors present clear proof of concept for Smart Baby Incubator that automate environmental monitoring and control using IoT, machine learning, technologies. Their system demonstrate how incubators can go beyond being passive equipment, instead acting an intelligent response caregiver. A key contribution is the focus on real-time alerting in neonatal care. Even a small delay in response can be critical. Their system raise immediate alerts when abnormal conditions like temperature changes or distress in infant uh, are detected. This significantly improves safely. Let's move on next slide. In terms of future improvement, the paper outlines several promising directions. One is the use of more advanced machine learning algorithm, particularly for high analysis with better models. The incubator could distinguish between cries caused by hunger, pain, or discomfort, offering more meaningful alerts. They also propose expanding the sensor suites including raspberry rate sensors or integrate weight scales. These additional would help provide a more comprehensive view of the infant health and improve automated decision making inside the incubator. Let's move on next slide. The paper also discussed how this smart incubator could be integrated into hospital system, maximize its effectiveness by connecting with electronic health records and nurse call system. Alert could be automatically routed to the appropriate medical staff, and health data could be logged in real time, improving workflow and reducing manual input errors. Automated monitoring and early warning system. This study is an excellent example of how modern technologies like IoT and AI can be applied to real-world healthcare problems. It shows that innovation in neonatal care can be both life-saving and accessible. Thank you for all your attention.